Hello everyone. So in this lecture, we are going to talk about the metrics and KPIs related to data governance. So metrics and KPIs are essential for measuring the effectiveness of data governance initiatives. They help organizations assess how well they manage their data sets, ensure compliance, and maintain data quality. So here are some of the key metrics and KPIs commonly used in data governance. First is the data quality metrics, in which we have accuracy rate, completeness, consistency, and timelines. So, accuracy rate is the percentage of data entries that are correct. The formula for this will be number of accurate data entries divided by total data entries whole multiplied by 100. So, by this formula, we'll get the accuracy rate, which is the percentage of data entries that are correct. The second is completeness. So it is percentage of data fields that are filled out compared to the total expected. So formula for this will be number of complete records divided by total records whole multiplied by 100. The third one is consistency. It measures the degree to which data across different databases and systems is uniform. Again, the formula will be number of consistent data points whole divided by total data points, again multiplied by 100. The fourth metric, the fourth data quality metric is timeliness, which is measures how often data is updated or refreshed to ensure it reflects current conditions. So formula will be total number of timely updates divided by total data points whole multiplied by 100. So suppose if we want to find out the accuracy rate, we'll have we and the number of accurate data entries are 20 out of 100, suppose. So 20 divided by 100 multiplied by whole multiplied by 100, it will give 20. So 20% will be the accuracy rate. Similarly, we can find out the completeness, consistency, and timeliness. The second is data compliance metrics. In this, we have regulatory compliance rate, audit findings, and incident response time. After this, we have data access metrics, data stewardship metrics, data governance process metrics, business impact metrics, overall data governance maturity metrics. So in the second one, the data compliance metrics, we have regulatory compliance rate. So the percentage of data processes compliant with relevant regulations. Example GDPR, HIPAA. Formula for this will be number of compliant processes divided by total processes whole multiplied by 100. Audit findings, number of compliance related issues that are identified in audits. Incident response time, which is the average time taken to respond to data breaches or compliance incidents. The third one is data access matrix, which is the access approval rate. So it helps us to find out the percentage of access request approved versus denied. So suppose if we want to find out the percentage which are denied, so it will be number of approved access request divided by total access request whole multiplied by 100, and this will be minus by 1. So for denial, it will be 1 minus the access rate, which can give us the denied rate. We can derive many much formulas like this. The second one is user access review frequency. Frequency of reviews conducted to ensure users have appropriate access levels. The third one is unauthorized access incidents. So it gives the number of incidents that are unauthorized access to data occurred. The fourth one is data stewardship metrics. The first point in this is data steward engagement rate. So percentage of data stewards actively involved in governance activities. So formula for this will be number of engaged data stewards divided by total data stewards multiplied by 100. Next is training completion rate. So this is the percentage of employees who have completed that data governance training. Formula for this will be number of trained employees divided by total employees multiplied by 100. So this specific metrics can be used to determine the continuous improvement aspect. If we can find out what is the training completion rate, so it can be very well said that the persons who have done their training, who have completed training, it can be the first point which can be taken care of, that if an employee has completed his or her training, then they are in line according to data governance policies and for their implementation. The amount which they have learned from the data governance training and all is a different aspect. We can discuss on it later, and it is a very debatable thing. But yes, the efficiency can be found out by many more tests and examinations, maybe some real life case scenarios. But the initial phase can be easily taken out by using this metric. The next is data governance process metrics. In this, we have policy implementation rate, policy review frequency, and change in request processing time. So policy implementation rate is the percentage of data governance policies that have been implemented across the organization. Formula for this is number of implemented policies divided by total policies hold multiplied by 100. Policy review frequency is the number of times data governance policies are reviewed and updated annually. The next is change request processing time. Average time taken to process changes in data governance policies or procedures. The next is business impact metrics. In this, we have a data-driven decision rate, percentage of decisions made based on data insights versus intuition or opinion. The formula for this is number of data-driven decisions divided by total decisions multiplied by 100. The second is cost savings from improved data quality. Financial savings realized from reduced errors and improved data-driven processes. The third is time to insight, which is the average time taken to derive insights from data, impacting decision-making speed. The seventh is overall data governance maturity metrics. So data governance maturity score, which is an assessment score indicating the maturity level of data governance practices. It is usually based on maturity model. Stakeholder satisfaction rate. So feedback from stakeholders on the effectiveness of data governance initiatives, often gathered through surveys. Formula for this is number of satisfied stakeholders divided by total survey respondents, which is whole multiplied by 100. So we have seen around 7 Metrics and KPIs, which can be used to find out the effectiveness of our data governance practices which have been implemented within the organization. So establishing and monitoring these metrics and KPIs allows organizations to assess their data governance effectiveness and identify areas for improvement. By regularly reviewing these indicators, organizations can ensure they are on the right track toward achieving their target governance goals, which is ultimately leads to better data management, compliance, and strategic decision making. Now we'll talk about the one very interesting topic, which is data security. So, data security covers all the activities that involve protecting data, people, processes, and technology. It is critical to keep personally identifiable information, personal health information, trading information, and information about intellectual properties out of the hands of criminals, hackers, attackers, and competitors. The challenge is that data is volatile and no longer maintained in a single monolith. It is decentralized, which is it is distributed across many systems and environments. Distributed data makes it harder to control what users do when they get their hands on data. For example, will they combine data or perform an ethical analysis? It is also difficult to secure data without knowing its full context. HR data in relation to reorganization has a different meaning and value than it would have in the context of organizing a company outing or celebration. A far bigger problem is the large amount of data big companies are dealing with. The data layer is a melting pot. Data sources and owners and consumers' needs and requirements are all brought together. Each individual source and its corresponding data elements have a different context, quality, classification, purpose binding, owner, rating, and so on. As new sources with more data and more digital identities are brought into the data layer, their complexity grows significantly. Describing, governing, and protecting all this data requires an explosion of security levels and policies. Hence, data security within an enterprise organization is generally enforced by a dedicated security department led by the Chief Information Security Officer, which is commonly termed as CISO. The CISO is a senior level executive responsible for establishing and maintaining enterprise's vision, strategy, and process to ensure information assets and technologies are adequately protected. They work closely with the enterprise architecture and data governance departments to ensure that the security vision and goals are correctly incorporated into the overall enterprise. What is the current siloed approach? So there's a huge gap between what most enterprises have implemented and what experts advocate. Many consultancy companies use the term data centric security to emphasize that security should focus on the data itself rather than on networks, servers, or applications. However, in practice, the current security implementations focus mainly on silos, data warehouses, and data lakes because large amount of data and the combinations users can make mean high risks and extra attention. For APIs and event-driven architecture, the security model in many companies is implemented using different procedures, classification tools, and capabilities. Security in these architectures typically focuses on endpoints rather than on the data flowing through these platforms. Data classification and surrounding context barely play a role for operational use cases. So, in my view, a data centric security model must focus on all data and distribution patterns, which we are going to see in the next coming slides. So, unified data security architectures. The first one is role based access control and architecture based access control. So, the recommended approach for implementing data security is to incorporate security requirements into the architecture from the start. Successfully addressing the security risks requires to focus on two levels of control. The first level is data security control, which includes data access, data masking, data encryption, data usage monitoring, and data providers. The second level is infrastructure level, which focuses on isolation, network encryption, firewalls, etc. Role based access control and attribute based access control. For this, we'll see this figure. The ABAC model is standard reference architecture. The most fundamental part of the data controls is data access, which is the ability to access or retrieve data stored within a database or application. There are two popular data access controls models that determining who has access to data. First is role-based access control, RBAC, and second is attribute-based access control. We'll have a look on these models one by one. In most companies, they start with RBAC, which is the role-based access control, a security access method based on defining roles and corresponding privileges. The idea of this model is that every user or employee is assigned a role with a collection of permissions and restrictions. A user can access data and execute operations only if the assigned role has the correct permissions. The main disadvantage of role-based access control is the role explosion. Within any large organization, there will be a large number of different roles, departments, sub-departments, and different functions have subtle differences. Managing all of these roles can become a complex affair. So if you do not want to use a coarse-grained role model, you will likely end up with thousands of different roles. Another problem with RBAC is that it is static and cannot take into account contextual information such as user, location, time, device, and information. Hence, ABAC, which is attribute-based access control model, is more advanced security method that fixes the disadvantages of RBAC. Its policies combine different data attributes. These policies can come from the data itself, such as classifications of metadata properties, or from the system's context and users, can be roles, geographical location, device properties, and so on, and the actions that must be performed on the data, which can be reading, inserting, updating, or deleting. So ABAC comes with a recommended architecture, which is shown in this figure, which has the following components. The first is PEP, which is Policy Enforcement Point. The PEP is responsible for protecting the data. It inspects the data request, which is query, and generates an authorization request, which is sent to the policy decision point for validation and approval, which is PDP. At PDP, which is the core component of ABAC, it validates incoming requests against the security policies defined on all attributes. The PTB returns an approval or rejection decision based on the outcome of the policy. It then informs the PEP of its decision and the reason for approval or rejection. Then comes PIP, which is Policy Information Point. The PIP allows the PDP to use external source data, such as user attributes, invoking a call to the identity provider. The fourth one is Policy Administration Point, which is PAP. A PAP is a repository that manages all enterprise security policies. A typical PAP also provides monitoring and logging and has a user-friendly interface. So we'll discuss a example of ABAC, which can be a sensitive HR data, which is classified with the metadata attribute, the employee information tag. If a non-HR person tries to access data with the employee tag, the PDP, which is the policy decision point, returns a rejection. Attributes can also be combined with ABAC. The HR example can also be extended to the environment from which the person tries to access the data. Working from home or from the corporate environment might result in different answers. Next is identity providers. Within the RBAC and ABAC models, there are important components when applications work within a federated or distributed network. Identity providers, which are IDPs. So IDPs are external sources for retrieving attributes from the user. They offer user authentication as a service and are often used to handle sign-in processes for other systems such as websites, CRM application, and file servers. The best known IDP implementations are based on either Microsoft Active Directory AD or Open LDAP. For authentication, there are currently two popular open protocols, SAML and OpenID Connect. Here, SAML stands for Security Assertion Markup Language and is based on an XML standard for exchanging the authorization and authentication data. It is based on a product form from the OSS Security Services Technical Committee. OpenID works similarly to SAML but is more open and is used by big companies like Microsoft, Facebook, Google, PayPal, and Yahoo. OAuth is sometimes mentioned in this context. OAuth is different from SAML and OpenID because it is used only for the authorization process and not for authentication. One more concept is there, which is space is single sign-on SSO. With SSO, users have to authenticate only once or credentials such as username and password and can then access multiple applications without authenticating again. The next is security reference architecture. So for this, we have to refer this figure. So security reference architecture and data context approach, these 2 points we are going to discuss together. So now these two are the two building blocks for securing the data layer and solving the complexity of the exponentially growing amount of data. Its attributes and the security rules attached to it. Two major building blocks are used to solve this problem of managing complexity, which is SPE, which is Security Policy Engine. and the intelligent learning engine, which is ILE. So in this and the following sections, I'll explain what these components are and how they work with the existing building blocks of the architecture. The security reference architecture is based on the ABAC security model because ABAC, as opposed to RBAC, offers more fine-grained security rules needed to secure the combination of different data attributes. Excuse me. The attributes, as you can imagine, will be provided from the surrounding metadata repositories. The ones we discussed in the data governance section, the application repository, LOGS, data classifications, and purpose classifications. They all have a strong relationship with how data security must be enforced. In this data, which we can see, the data providers, data consumer, and layers are familiar, but the four security components on top of the architecture are new. Excuse me. Each security component fulfills a critical role and is expected to work closely with the other components. Each is numbered in in this example. So first is SPE, Security Policy Engine. So the SPE is the PDP responsible for governing a closed system of elements, which can be data providers, consumer relationships, etc., and their attributes. This component operates with a limited number of attribute variables so that it can be translated to policies and rules managing secure access to data. The second one is intelligent learning engine. The ILE provides learning capabilities to the SPE. It is responsible for handling the system in its evolving state and learning the models the SPE can use. This component by definition does not deal with a static, closed system of rules, but observes the dynamics of the open system, finding cluster patterns of security principles and attributes, as well as further serving as a governing mechanism and as an expansion of SPE rules and policies. The shared components layer is an abstracted layer of services that enables the enforcement of security functionality, such as the PEP, logging database, and infrastructure provisioning engine. The metadata stores contain all the data attributes, including security and privacy, as well as the data coming directly via the SPE and manual improvements from the security officer. The combined metadata stores act as a PIP for the PAP and SPE. The security components interact closely with each other. So after this, I'll next explain the process of data onboarding, providing, and consumption. So as we walk through each step, I'll refer to the components and explain their role in the architecture. So by the end of the next section, there will be a good understanding of how these components actually work together. So we'll discuss the security process flow. Data security within the data layer is assured by following the data as it moves through one of the integration architectures. To explain this, how it works, we have to look on at this figure based on the security architecture which I have discussed earlier. The process of how data is ingested, validated, and consumed has several steps. So we'll go one by one. So we have in this data ingestions, data at rest, access to data and data consumption, the last four steps which we are going to discuss in this. The first is data ingestion. The first step of ingesting data into an exposing data via the data layers starts by providing the data and additional metadata information. During this step, we expect each unique data set to be registered in the LOGS together with the corresponding data owner. A precondition for this step is that the application has already been registered in the application repository. Additionally, we expect all business metadata to be linked to the physical data. During the onboarding process, the data and its purposes should also be labeled and classified. So these processes can be accelerated with the support of machine learning capabilities to auto-classify the data. Such profiling products can automatically detect social security numbers, credit card numbers, customer names, and addresses. So as you provide more data, the artificial intelligence and machine learning tools get smarter, accelerate the processes by providing suggestions and improve the reliability of the classification. So step one is the providing of the data. So data providers provides the inputs data to the APIs, RDs, RDSs, and streaming channels. This is the step one. It is important to preserve the security context for operational use cases as well. Since this data can play a role in operational analytics, this means that local domain data such as sensitivity labels, countries, domain ranges, and the like must be part of the data or provided during the onboarding process. Without attaching this context to the data, it will be very difficult to implement finer grained security rules later. The second is data at rest. As the data is stored at rest, additional security measures kick in, depending on the company's risk appetite and security policies. Data can be automatically tokenized and encrypted. This step only applies to the RDS and streaming architectures because in those architectures, data can be persisted for a longer period. Data in transit should be encrypted on the infrastructure layer with other protocols, such as Transport Layer Security TLS or Secure Sockets Layer SSL. The third is access to data. So it's between security level and the data consumer. So data access by the data users is highly more complex because it involves multiple subsets. Data consumption starts with a data sharing agreement in which both the owners and data user agree on the consumption, use case, and purpose of the data. Without this agreement, data consumption shouldn't be possible. Once agreed on, a contract is stored in DSAA. The contract with its corresponding attributes are important elements for the SPE, which we'll discuss next. With the data sharing agreement in place, data consumption can start. This is where the magic happens. Multiple components kick in and work together to validate if access should be granted or not. This process of corresponding tasks are the basis for any additional decisions that relate to how the data is accessed or once permitted. Attributes from the PIPs are collected. They provide information about users or applications, their departments, groups, roles, purposes, start date within the organization, last successful sign-on date, and so on. All this information will be collected and combined for the next series of tasks. The next task is to collect the data, metadata, golden source classifications, application metadata such as confidentiality, integrity, and availability ratings, production status, data classifications corresponding business capabilities, whether data is automatically accessed or combined with other datasets, etc. The third is the metadata of the target application, such as ratings of the consuming application, production status, and runtime details are collected. The fourth is the surrounding metadata stored are queried, such as logging database with a previous access times, telemetry data, or infrastructure information. The last task is to combine all this information and submit everything to the SPE to make the decision. The SPE makes decision based on sets of rules that in practice govern the combinations of attributes give what type of answers. Based on the request and matching rules, data consumers will be granted access or denied the access. The rules also tell the consumption layers what data consumers are allowed to see and how. For example, some data can be hidden while other data can be anonymized by using masking techniques. The final subtask is to submit the request, its corresponding information, and a decision to the security logging database for future analysis. Now we'll discuss the data consumption. Based on the consumer's security request, the SPE automatically decides what data can be accessed and how it must be consumed. Depending on the security rules and context submitted during the request, additional components can be invoked. So we'll discuss few scenarios. The enforcement happens in real time as users with SSO or applications try to access data. Queries are intercepted, decisions are made, and data is returned. A consumer-specific view is automatically created within the RDS architecture from which the consumer wants to consume. Based on what the SPE has decided, certain data can be hidden, masked, or scrambled. For this type of functionality, the RDSs are expected to work together with data security tools like Apache Ranger, Apache Sentry, Axiomatics, Private Protegrity, and Informatica's Secure at Source. For specific purposes, ad hoc reporting like ad hoc reporting or data exploration, access can be granted only to specific tooling or with an expiration time. Wrangling tools, for example, can be given access to the data in specific situations for a limited time. Data can be duplicated and pre-processed specifically for a certain project or use case. During the processing step, data can be masked, hidden, filtered out, tokenized, or scrambled. This scenario works well for very large datasets. For API calls and events, certain blocks within JSON message are filtered or removed via an additional security layer. Custom-made topics are provisioned on a streaming platform that only contains messages specific to the consumer. After the SPE has granted access to the data, the journey continues on the consuming side where we see applications and capabilities. Now we'll see the data processing at consumer side. Data is secured in the RDS architecture as described by in the last slides by utilizing metadata from various repositories. For example, a cloud policy could enforce encryption for data at rest at the consumer side or automatically grant specific resources to the data. Next is onboarding again. So the moment the consumer becomes a data provider, the process flow closes and the steps must be repeated. The amount of metadata and number of steps can be overwhelming initially. So I generally recommend that slowly building up the security architecture. One should start with the basics by collecting the most important metadata and creating a limited set of classifications and a few consumption patterns. So as one gradually progress, extend the architecture further and more advanced capabilities and metadata. Finally, we can make it more self-service to scale it up further. Now we'll discuss the RDS architecture, which I've taken name few times. So data is secured in the RDS architecture by utilizing metadata from various repositories. Consumption starts with the basic ingredients like ownership information, classifications, relationships to physical data objects, and data sharing agreements. With this recipe, we know what data users are entitled to consume. On the other hand, we have security policies. They make sure users can access only the data they need for their job profiles and use cases. In other words, they technically enforce what data access controls should be applied to the data. These policies take the data sharing agreements and all other data governance and things. So summarizing this thing, so data governance and data security are heavily intertwined. Data governance is a critical success factor in building up a modern data practice to stay compliant with strong regulations. It is important to define ownership and set standards for lineage, classification purposes, and descriptions. For these tasks, it is also key to identify all applications and unique sources, which are also called as golden sources across the organization. To make data governance scalable, one needs to identify related roles and responsibilities and assign them properly. So one should always start small and strive for quick wins. For data security, it is important to create an end-to-end framework that efficiently supports the data request fulfillment process. This framework is the start of an enhanced security model within the data layer. It must be a sensible part of the overall architecture. So as one progresses so slowly, extend it with mode metadata, classifications, labels, attributes, and so on. To scale it further, one can make it intelligent by machine learning. So here we finish the basics of data governance and data security. So in this we have seen the security process flow, which has data ingestion, data at rest, access to data, data consumption, data processing at consumer side, and data onboarding again. In the next slides, we are going to discuss about the best practices. And we'll also discuss two case studies to give a practical perspective for this data governance course. So I hope you are with me in this data governance course till now, and we'll end this lecture on a very good note by discussing two practical real-time case studies, which will give us a more practical approach toward the data governance and how it is actually implemented in real world in the large organizations, which we'll discuss in our last lecture of this data governance series.